All right, in doing that, what did you discover? Some things that I hope you saw was that if we factor and solve our parentheses equal to 0, we're going to get the x-intercepts. If we get the x-intercepts, the line of symmetry, halfway in between. What else? If we have the line of symmetry, that can take us to the vertex, because the vertex, the x value, is on the line of symmetry, and then plug in to find y. Okay, and then we've got to understand that the stretch and compress behaves just the same as if we were in vertex form. All right, so there are 3 forms of a quadratic, and there's good stuff that comes from each of them. So vertex form, we said many times, the important thing that comes from that is the vertex, right? That is at HK. Factored form, the thing that we're now finding is that that gives us the x-intercepts. Standard or general form. The easy thing that comes from this is the y-intercept, because the y-intercept happens when x is 0, and if x is 0, that term goes away, that term goes away, and it is just our c value. All right, so knowing that parabolas are symmetric, what should the x value of the vertex be? Well, the x value of the vertex is going to be on the line of symmetry, and the line of symmetry is going to be halfway between. So if we see that those are 6 apart, we know that the line of symmetry is going to be at x equals -1. So we know that the vertex is going to be at -1 something, and we can plug in to find that value. Okay, so if we go to this, let's put these back in. Oops. Okay, so if I put -4 and +2, and I know that my line of symmetry is at x equals -1. What you should have found in your exploration is that if I plug that in and say -1 for all my x's, I'm going to get that y equals 3 times -3, which is -9. So then I would be able to plot that point right there. Okay, so the thing I have to know from here, if I want to graph the whole thing, is that my a value, because I would multiply x times x and get x squared. So my a value is just 1. So now this is going to behave just like any other one. When I go out 1, I shouldn't say like any other one, it's going to behave like the parent. Out 2, up 4, out 3, up 9, and that's where I get to the values that I already plotted. So I can graph that. Okay, so if I'm graphing in factored form, The important things we need to be able to do is find the x-intercepts, and we do that by setting each of my parentheses equal to 0. I'm going to find the line of symmetry, which is halfway between those two. I'm going to find the vertex by using the x value of the line of symmetry and evaluate the function to figure out what the y is. And then I can also find the y-intercept when x is equal to 0. So you may want to pause the video and write that down if you need to. We're going to do some examples. So if I'm graphing this, first I need to understand that this is kind of like saying that my first, whoops, oh my goodness, there we go. My first parentheses, x minus 0, tells me I've got an x-intercept at 0. My second one, x minus 4, tells me if I solve it, I have x equals 4. Okay, then I'm going to find the line of symmetry that is halfway in between. So that's at x equals 2. I'm going to plug in 2. So I'm going to say f of 2 is equal to negative 2 times 2 minus 4. So I'm going to have negative 2 times negative 2, which is positive 4. So I'm going to have a point up here at 4. And if you see how this is setting up, it's going to be vertically reflected, which makes sense because I've got a negative a value. Okay, I've already got the y-intercept. So what I would be doing as I look at this is understanding that the a value is 1. So what should happen is behavior just like the parent function when I go out 1, down 1. So that would give me some other points. Out 2, down 4 gives me those x-intercepts. And if I've got those 5 points, I can probably draw a very nice graph. Okay, so I would pause the video, try this one, and now I will show you the solution. So again, solve each of these to figure out that I've got x equals negative 1, x equals 5. Go halfway in between, so they are 6 apart. So when I go halfway in between, I'm going to be at x equals 2. Plug in 2 to the function and evaluate. So I have the opposite of 2 plus 1, 2 minus 5. So I have 3 times negative 3, so negative 9, but take the opposite. That is 9. So my point would be up here at 2, 9. I can find the y-intercept by plugging in x as 0. So I'm going to get the opposite of 0 plus 1, 0 minus 5. So I'm going to get negative 1 times negative 5. So that is positive 5. So I've got that up here. And I can then have a symmetric point on the other side of my line of symmetry. And again, those 5 points are going to allow me to make a nice graph. So you can keep practicing these, or hopefully that is enough. This one, the big deal is that if I look at this, I've got x-intercepts at 3 and negative 1. That means I have a line of symmetry halfway in between. That would be at +1. I'm going to get my vertex by plugging in 1 because that's my line of symmetry. So I have 2 times 1 minus 3, 1 plus 1. That gives me -8. So I go down here. I have this point at 1, -8. If I want the y-intercept, I'm going to plug in x as 0 and get 2 times 0 minus 3, 0 plus 1. So I've got 2 times -3, which is -6 times 1, still -6. So I'm here. If you look at that, and here's the kind of important part, when I go out 1, I'm going up 2. That comes from my stretch factor of 2. Okay, I'm going to stop and start different.